Black holes are among the most intriguing objects in the universe. They captivate both scientists and the general public. These cosmic phenomena challenge our understanding of physics and the nature of reality. Imagine falling into one. What would you experience? The idea of black holes has been a staple of science fiction. Movies and books often depict them as mysterious and dangerous. But what does science say? How do black holes form, and what happens if you fall into one? Let's explore these questions. Understanding black holes requires diving into complex theories. But don't worry, we'll break it down step by step. By the end of this essay, you'll have a clearer picture of these fascinating objects. Ready to embark on this cosmic journey? Let's get started. A black hole is a region of space where gravity is so strong that nothing can escape from it, not even light. This intense gravity occurs because a massive amount of matter is packed into a very small area. Think of it as a star that has collapsed into a point of infinite density. Supermassive black holes have masses equivalent to millions or even billions of suns. The boundary around a black hole is called the event horizon. At the center lies the singularity, where gravity is infinitely strong. Black holes form through a process involving the death of massive stars. When a massive star exhausts its nuclear fuel, it can no longer support itself against gravity. The star collapses under its own weight. This collapse leads to a supernova explosion, ejecting outer layers into space and leaving behind a dense core. If the core's mass is above a certain limit, it continues collapsing. Eventually, it forms a black hole. This process is a natural part of the life cycle of massive stars. Stellar mass black holes are the remnants of these collapsed stars. Supermassive black holes, on the other hand, have more mysterious origins. They may form from the merging of smaller black holes or from the collapse of massive clouds of gas. Scientists are still researching how these colossal objects come into being. Regardless of their size, all black holes share the same basic structure, an event horizon and a singularity. Understanding how black holes form is crucial to understanding their nature and behavior. It's a process that highlights the incredible power of gravity in shaping the universe. The event horizon is the point of no return. Once you cross it, escape is impossible. This boundary defines the black hole's size. At the very center lies the singularity. It's a point where the density is infinite and the laws of physics break down. The singularity is a mystery. It's a topic of intense research and speculation. Section 5. Falling into a black hole. The initial stages. Imagine you're falling toward a black hole. At first, you might not notice anything unusual. From a distance, a black hole looks like any other massive object. But as you get closer, things start to change. The gravitational pull becomes stronger. As you approach the event horizon, the effects of gravity become more pronounced. You would experience intense tidal forces. These forces stretch your body in the direction of the black hole and compress it in the perpendicular direction. This process is known as spaghettification. The closer you get to the event horizon, the more extreme these effects become. Eventually, the tidal forces would become so strong that they would rip your body apart. This is not a pleasant experience. It's a dramatic demonstration of the power of gravity near a black hole. Falling into a black hole is a one-way trip. Once you cross the event horizon, there's no turning back. The journey toward the center is marked by increasing gravitational forces and the ultimate fate of being stretched into a thin, elongated shape. Section 6. Spaghettification, the ultimate stretch. Spaghettification is a dramatic but accurate term. As you fall toward a black hole, the difference in gravitational pull between your head and feet becomes extreme. This difference, known as a tidal force, stretches your body into a long, thin shape like spaghetti. For a stellar mass black hole, spaghettification happens outside the event horizon. The tidal forces are so strong that they would tear you apart before you even reach the event horizon. However, for a supermassive black hole, you might cross the event horizon before spaghettification occurs. Inside the event horizon, the stretching continues. The closer you get to the singularity, the stronger the tidal forces become. Eventually, your body would be stretched into a thin stream of particles. It's a gruesome fate, but it highlights the incredible power of gravity near a black hole. Spaghettification is a vivid example of the extreme conditions near a black hole. It's a process that underscores the intense gravitational forces at play. While it might sound like science fiction, it's a real phenomenon predicted by the laws of physics. Section 7. Time dilation near a black hole. Einstein's theory of relativity tells us that time is not constant. It can be stretched and compressed by gravity. Near a black hole, this effect becomes extreme. As you approach the event horizon, time slows down relative to an outside observer. Imagine you're falling into a black hole while your friend watches from a distance. To your friend, it would appear as if you're moving in slow motion. The closer you get to the event horizon, the slower your movements would appear. At the event horizon, time would seem to stop altogether. For you, falling into the black hole, time would seem to flow normally. But from the perspective of an outside observer, you would appear frozen at the event horizon. This effect is a result of the intense gravitational field near the black hole. Time dilation near a black hole is a fascinating consequence of Einstein's theory of relativity. It shows how gravity can warp space and time. Understanding this effect helps us grasp the strange and counterintuitive nature of black holes. Section 8. Theoretical ideas inside a black hole. What happens inside a black hole? This question has puzzled scientists for decades. One idea is that the singularity at the center could be a gateway to another universe. This concept is based on the idea that black holes could connect different regions of space and time. Another theory suggests that black holes could contain wormholes. These are hypothetical tunnels through space-time that could connect distant parts of the universe. If wormholes exist, they could provide shortcuts for traveling vast distances in space. Some scientists propose that black holes could lead to alternate universes. This idea is based on the concept of the multiverse, which suggests that our universe is just one of many. If black holes are gateways to other universes, they could provide insights into the nature of reality. These ideas are speculative, but they highlight the mysterious nature of black holes. They challenge our understanding of space, time, and the universe. Exploring these theories helps us push the boundaries of our knowledge and imagine new possibilities. Section 9. Wormholes and alternate universes. Wormholes are a popular concept in science fiction, but they also have a basis in theoretical physics. A wormhole is a tunnel-like structure that connects two separate points in spacetime. If they exist, wormholes could allow for faster-than-light travel. Black holes are thought to be possible entrances to wormholes. The intense gravitational forces could warp spacetime, creating a tunnel-like structure. However, this idea is still highly speculative. We have no direct evidence that wormholes exist. The concept of alternate universes is also intriguing. If black holes are gateways to other universes, they could provide a way to explore the multiverse. This idea is based on the theory that our universe is just one of many. Each universe could have different physical laws and properties. These ideas are fascinating but remain in the realm of theory. They challenge our understanding of reality and open up new possibilities for exploration. While we may not have concrete evidence, the study of black holes continues to inspire new ideas and discoveries. Section 10. Recent discoveries and scientific studies. In recent years, scientists have made significant discoveries about black holes. One of the most groundbreaking was the first ever image of a black hole, captured by the Event Horizon Telescope in 2019. This image provided direct visual evidence of a black hole's event horizon. Another exciting discovery was the detection of gravitational waves. These ripples in spacetime were first observed in 2015. They were caused by the collision of two black holes, providing new insights into these mysterious objects. Scientists study black holes using a variety of methods. Telescopes observe the effects of black holes on nearby stars and gas. Computer simulations help researchers understand the behavior of black holes. Gravitational wave detectors provide new ways to observe black hole mergers. These discoveries and studies are expanding our understanding of black holes. They provide new evidence and insights, helping to answer some of the most fundamental questions about the universe. As technology advances, we can expect even more exciting discoveries in the future. Section 11. Recap and reader engagement. We've explored the fascinating world of black holes, from their formation to the mysterious singularity at their center. We've discussed spaghettification, time dilation, and the theoretical ideas of wormholes and alternate universes. We've also touched on recent discoveries and how scientists study these enigmatic objects. Black holes challenge our understanding of the universe. They push the boundaries of physics and inspire new theories. They are a testament to the incredible power of gravity and the mysteries of space-time. What do you think about black holes? Do they fascinate or terrify you? Share your thoughts and questions. Exploring black holes is a journey that combines science and imagination. It's a journey that invites us all to wonder about the universe and our place in it. Thank you for joining this cosmic adventure. Keep exploring and stay curious. The universe is full of mysteries waiting to be discovered.